Hi Pre-Calc, we're going to do 4.4 trigonomic functions of any angle. That's where you're going to evaluate the angle in any of the four quadrants using a 30, a 45, or a 60 angle, or a quadrantal angle. Alright, so let's first go over the definition of a reference angle, because this is the basic tool you're going to use. Let theta be an angle in standard position. Okay, you guys know what standard position means. That means it has to start from the positive side of the x-axis. Its reference angle is the acute angle theta prime. Again, acute means less than 90 degrees, formed by the terminal side of theta and the horizontal axis. So this part doesn't seem important. It's huge. It's everything. The terminal, so how you create theta prime, the reference angle, is it's the angle in between the vector of the terminal side and the vector of the horizontal axis. Okay? Alright, so in quadrant 1, if you have an angle that's in quadrant 1, and this is my standard angle, so this is in standard position, this is my initial, this is my terminal. So how you find the reference angle, it's from the terminal to the horizontal. So for quadrant 1, theta and theta prime are equivalent. They're both acute, and it will satisfy the rules for theta prime, being that it has to be between the terminal side and the horizontal x-axis, which it is in quadrant 1. All right, now let's create. By the way, these are just basic templates. Of course, if you like double or triple wrap, or you have a negative orientation, you have to modify these rules. I'm just giving you the basic template of these rules and how to find theta prime from them. Okay, now let's rotate into this second quadrant. Okay, so theta is my original angle. I'm going to show you how to calculate theta prime. So theta prime always goes from the terminal side to the horizontal, never the vertical. Don't ever go to the vertical. It's always the horizontal. So whatever quadrant you're in, just make sure you go to the horizontal. Okay, so that means that theta prime is actually the angle in here. Remember, it has to be acute, so it has to be less than 90. This angle is obtuse. This is greater than 90. Okay, so, but we need this guy. So to calculate theta prime, think about how you might do that, how you might calculate it. Because a lot of times when you're doing this, if it's double wrapped or it's a negative wrapped, it's sort of like figuring out, you have to basically figure out the magnitude of this. So how you could figure out the magnitude of this is it's pi minus theta. Because if you go all the way to pi, but then you subtract theta, you take away this part, it's going to leave you with this slice. And again, this can be in this can be in degrees as well. So just another way to write the same thing is this. And so this would be how you would calculate theta prime in general for quadrant 2. All right, now let's do quadrant 3. Let's say you're rotating into the third quadrant. So your original angle in standard position rotates into the third quadrant. You need to figure out what theta prime is. Again, theta prime is always from wherever your terminal side is back to the horizontal. So in some cases, the horizontal is below you. In some cases, the horizontal is above you. So either you're going to come down to the horizontal or you're going to go up to it. But that's pretty much it. So theta prime is going to be this guy in here. Remember, it has to be acute. That's the definition. So theta prime is this triangle right here. Okay? Now, how would we mathematically calculate that? So let's think about that. Theta prime here is going to have to equal, well, we've gone past pi, so it looks like it's going to have to be theta, the bigger angle, right? This big angle. If we take away pi, then we'll be left with the slice that we want. And again, this can be done in degrees, where you would do theta minus 180 degrees. So just, if you start with degrees, stay in degrees. If you start with radians, stay in radians. Okay, let me show you the last one, and I won't, I'll wrap up this video so it's not super long. Okay, so now in standard position, now let's rotate into quadrant 4. Okay, so here we are in quadrant 4. So again, theta prime has to be from the terminal side back to the horizontal, which in this case would be here. I'd have to go up to the horizontal. So in here, this acute angle is theta prime. Now we have to figure out how to calculate theta prime. So how do you think we might do that? Good. I hope you figured out that we didn't quite make it to 2 pi. So 2 pi minus theta, minus all of this, would just leave me with this slice. Or again, if you're in degrees, you want to think of it as 360 degrees minus theta. Okay, gang, that is how you do the general calculations for theta prime. In the next video, I'll show you how to use it. Okay, hope you enjoyed that. Catch you soon. Bye-bye.